Hey guys, Bukoid here. I'm going to give you an update on what's going on since yesterday, my video. Yeah, I still think something is fishy going on here. They've either completely missed what's going on, all the models missed it, but that's not the case because the models are picking something up and their forecasting models don't even have it on there. And that's exactly what I was saying yesterday. They took it off of there for some reason, and I don't know why, but it's too much of a coincidence to see this thing actually hit us, and for them just to take it off all the models, just to wipe it all off, except for one. I'm seeing it on the CME tracker, but they don't update that unless it sees a new CME. So whatever it was showing before is going to stay that way until the next CME. That's on the CME tracker, and I'll explain a little bit here in a minute. But I'm going to start you guys off here at spaceweather.com. Okay, I've been showing you guys this site here for a few now. I think it's a good site here, guys, but check it out. No CME, no problem. Okay, they were puzzled by this too, a little bit. You can tell by the way that this was written. It says a slow-moving CME that was expected to hit Earth's magnetic field on October 29th, which was yesterday, okay, has either missed, been delayed, or its impacts was too feeble to notice. No CME, no problem. Arctic skywatchers may still see auroras tonight and tomorrow as Earth enters a stream of solar wind flowing from a southern hole in the sun's atmosphere, okay? So, again, it was supposed to be here on the 29th by their models, okay? Now, sometimes their models are wrong, okay? Like I said before, that they don't know how fast these things are moving until it hits the detectors, okay? They don't know exactly how fast. And that's why we have to take that solar wind speed and do some math with it so we can calculate back when it left the sun. And if we do that and we look and then we see something on the sun at that time, then we can confidently say, hey, yes, that is the CME. And that is exactly what happened. Okay? Not to mention that sometimes these things will change speed. Okay? Whatever happens out in space, sometimes things change its speed a little bit. All right? So, I mean, and all that stuff's a possibility, you know. I mean, the sun's 93 million miles away, so that's a lot of room for something to change for them to be able to do it in a very accurate way. And this is why I don't come out and say, oh, that CME missed us right away, okay? And they're not saying this either. They're just saying, hey, you know, it was supposed to be here on the 29th, and it's not here, and here's some of the reasons why it could be. And that, you know, and I respect that because, you know, this is something that really most should do. Most should say this until, you know, 2 or 3 days after. Then maybe you could come out and say, hey, yeah, we were supposed to see that CME, but it never hit us. You know, did it go in a different direction? Was it not as powerful as what it looked like? Was it moving at a completely different speed? Did it just not have the energy really to do much to our magnetosphere? Okay, so those are all the possibilities, but given the fact that what happened yesterday when I showed you guys that model on the geoelectric field and all the other models, and I'm going to run through some of these, okay? Okay, this is Space Weather Prediction Center. So what we got here, and I show you guys this all the time. You guys know that. Those of you guys that are new, this is the solar wind speed, what this is saying the solar wind speed is. And there's the geomagnetic storm level as high as it's got in the past 24 hours. Which is no geomagnetic storm. Now, I will say this. The activity is increasing a little bit. It's even showing on their models. Okay? As you can see here, it was up here and then it kind of bumped down, and it looks as though it might be creeping back up. Now, it could be because of a new solar wind stream from a coronal hole or the CME. Now, and I'm going to show you another model here in a minute that is showing you that we took a pretty decent hit. And it's ongoing as we speak. These models may have not caught up to it yet. I don't know. Because it just now happened is what I'm trying to say. So we're going to wait for some more data to come in, and I'm going to come back with another update. But I do want to tell you guys that I do believe that CME is now hitting us. Just judging by the models. So, as we're looking at this, and this is why, I looked at this about an hour ago, okay? This is the solar wind speed, okay? It was steadily going down. And about an hour ago, this was even, because of the way the graph is set up, the numbers were a little bit smaller. So this thing actually was almost on the bottom. There was nothing there almost. It's like it just bottomed out, right? Well, if you look here, you can see a slight uptick in the speed, like it's starting to ramp up for whatever reason. Okay, and to explain a little bit better, you see how it kind of went down here, right? Well, now it's up here, so it is coming up slightly. Now, whether that trend continues, again, I can't say. Nobody can say, guys, until these hit the detectors. That's my whole point here. They change these models like that, and they shouldn't until it really, computes itself. It comes in, the data gets there. Now you can see that the density is doing the same thing, okay? We would expect the density to go up as the solar wind speed went down, but when that solar wind speed started coming up a little bit, it started coming down, right? Well, now we got this little thing is kind of coming up too. Now, why am I saying that? Because a lot of times with CMEs, the density and the solar wind speed go up at the same time. Now, if it's a solar wind stream from a coronal hole, typically they go opposite. Okay? That's what I'm trying to say. So that's another indication that's saying, hey, maybe this is that CME that they said, didn't hit us yet. And all the models, they took it off all of their models. It's just ridiculous. Look at this. This is the Enlil, okay? Now, this isn't showing CMEs. None of those models I'm showing you right now is saying, hey, there's CMEs here or CMEs there. All these are doing is just giving you other data, but the data itself can show you a CME or what's indicating a CME. So if we look at this, and I'm going to run the model because there's nothing here that is showing a CME at all. Or, even a slight, it's just showing very slight upticks in the solar wind speed and the density. The density's flatted out, man. I mean, look at that. And I showed you guys this yesterday, how the model didn't even look like this, not even close, 2 days ago. They completely changed it. I mean, I don't know why, is what I'm trying to say. And then like I said, with the geoelectric model that I showed you yesterday with the massive geoelectric stuff that was going on right around the California area. And actually, I had a subscriber, and I'll take you guys to that here in a minute. Sent me a link that he took some recordings that I didn't catch. Thank God he recorded it, because I don't think anybody else did. I mean, that's a good catch, and I do appreciate that, man. I really do, because he sent me a link to it, and I'm going to take you guys to it here in a minute. But it shows you from where I showed you guys yesterday back a few. Okay, he actually caught the end of it, but that model only runs for like 2 hours, and then it re-updates. Okay, it's a rolling update, but it only goes backwards 2 hours. So he was able to catch that and catch what happened before I showed you guys that capture yesterday, and it's pretty crazy. All right, guys, here's that link, okay? As you guys can see, this is Troy Manning. Obviously, he doesn't run a channel. You can see by his subscribers. I'm not sure if he's interested in running a channel, but as far as I'm concerned, if you're able to jump into this like that and have the foresight to actually do that and actually record it and have the mindset to do that kind of thing, I think you should. I think you should jump right into this and try to do something, man. I really do, man. I really appreciate this, Troy. This is awesome. Now, if you don't have the time, and I get it. I really do. But I'm just saying, I would support you and try to help you as much as I could if you wanted to try to start your own channel. But anyway, as we got here, guys, and he even told me, because he sent me a comment, he actually took the time and effort to download a screen recorder that he didn't even have just so he could do this. I think that's awesome. I mean, that's the kind of effort that is awesome. I mean, awesome. So anyway, I'm going to play this, okay? This, what you're looking at right there is the actual capture I took yesterday, okay? So that is where it starts, and he's going to show you in this video here that, yeah, stuff was going on before this, but it was always on that side of the country too, okay? So I do think that they think that, I think they knew that this was coming, is what I'm trying to say. Okay, so watch it. I may have to back it up. We'll see. Okay, this is the time lapse, okay? This is what it does during the time lapse. You can see it bouncing around a little bit. See, look at that. Boom. Something right there hit us. Okay? There's no other way around it. Something hit us right there. And no other models, nobody talked about it. They didn't, nobody. I mean, it was nothing. It was crickets. Okay? Now, you know, if this model was never out there, would I be sitting here talking about it? Probably not, because I probably would have missed it too. But this is a new model. This is my whole point on this. This is something that is brand new. And this is showing us something, and we need to pay attention to it, because none of the other models picked it up. So we'll run this again. And I guess I'll try to pause it when it starts doing its thing. Crud. Okay, let's back it up a little bit. See if I can't stop it. Okay, guys. I'm going to show you what I'm talking about. This is where I first seen it. Okay, when I seen that something was a miss here, I guess you could say. That's the solar wind speed up there. Okay, that's what that's trying to show you. Now watch. Okay, not to mention you're going to see these smaller waves are coming in. Okay, you see that? Now sometimes that happens out in front of a CME, or that could just be solar wind stream that's been increased, which we've been talking about anyway, because of a smaller coronal hole or even a larger one. That could be some of that energy is what I'm trying to say. Okay, and sometimes they combine, like I said before, and we get bigger hits because of it when they combine. Now, something I want to point out here. If you look at this, typically when you look at this magnetosphere model, this is the solar wind one, but it should be very symmetrical. Okay, what I mean by that is if the sun's over here, right, which it is, then the energy coming from it, it would make sense if it's 93 million miles away that it would, you know, kind of spread out as it comes our way, and we would see symmetrical hits. You know, it would be kind of even. In other words, this blue that's here, it should pretty much be up here too, if we're getting hit the same way, as far as the energy hitting our magnetosphere. Okay, so that what I'm trying to say is right there that we are not right there. This is different. This is coming from a specific direction, which is also indicative of a CME. Okay, because CMEs blow off from a specific spot, but sometimes they're more precise than just solar wind. Okay, so when we see these things that look kind of directional, that kind of does point towards a better chance of a CME that's causing it. All right, now so what we got here, and watch that solar wind speed up there. Okay, you see how it's just hanging around 4, getting up to 5, and then it will go back down to 4. But you're seeing big red colors and stuff there, but the wind speed ain't rising. Well, that's probably because the density's probably higher right there. The wind speed doesn't have to rise for us to get a hit. Now, if you look at this, now I understand that this is a solar wind model, okay? The detectors are the satellites that circle the Earth, right? And it's meant to catch stuff coming from the front, right? The solar winds. But it doesn't mean that we should not look behind it, okay? That, when you see signatures like that isn't normal, we should at least stop and look at it and say, hey, well, why is that not normal? Even if it isn't, and I ain't saying that it isn't, but even if it isn't exactly what it's showing you, we can still compare what's normal to not normal and say, hey, what's going on? Okay, that's my point there. So whatever your beliefs are as far as what these models are actually able to show us behind here, what I'm doing here is showing you what's normal compared to not normal. And this is not normal. Okay? So as we go here, you can see, I mean, when we start seeing stuff like that, now look, that looks pretty symmetrical. Okay? See how it's kind of symmetrical? Now, but as we get further on into the time lapse here, you're going to see it get lopsided. Okay? As we go, now watch this. Okay, you see that? Look. Now, see the arrows? It's blowing that direction. If this was a symmetrical hit, these arrows should be going the same way as that, and they're not. So this came at us from a specific direction, is what I'm trying to say. Okay? So, as you can see, look at that. I mean, it blows up pretty big right there. Now, we've seen that stuff before 100 times, okay? But it doesn't mean we shouldn't look at it, guys, is what I'm trying to say. Now, watch the solar wind speed up here. Okay, it's already creeping up right there. Okay? No, that does not say 666. That's 686. Okay? All right, now watch. Watch what happens. 1,000. Okay, that's 13. I want to see how high it got. Does that say 15? That says 1454. 16. Does that say 19? It sure does, guys. Look at that. Wow. So don't tell me that wasn't nothing to look at. I mean, nobody's going to sit here and even convince me that we shouldn't be looking at that. That's most certainly something we should pay attention to. Okay? And I do think that's probably that CME that they said was possible that could have missed us or slowed down or changed direction or wasn't as powerful. That's probably what's getting us right there. Now, I got to wait on some more data to come in, and we'll compute that to speed here in a minute. But okay, guys, this is the IMF model, basically. It's not really the IMF model. Anyway, it's showing our connection to the sun. I meant to say that the blue lines is the IMF. Okay, that's it's our connection to the sun. Interplanetary magnetic field lines is what that stands for. Okay, you can see how they're broken. That's why I'm showing you this model. Okay, now it's not unusual to see that broken like that. Let me start it back here. Okay, but this was earlier today, a few hours ago, about 12 hours ago. Okay, now you can see again what I'm talking about directional. Okay, why are we only getting disturbances on one side? Okay, you see how it's different? Also, you see how we're tilted like that? Well, right now, guys, we're below the ecliptic. In other words, we're south of the equator of the sun, basically, if you stretch it out. And that happens, at the equinox, so we kind of fall behind that. And sometimes we do tilt up in this season, okay? It does look as though we're tilting our magnetics. All right, now, it doesn't always stay like that. Sometimes we'll see it fluctuate back and forth. And sometimes we'll even see it like go the other direction a little bit and come pop back up. That's not completely unnormal, is what I'm trying to say. So if you see that, don't really freak out unless it goes like completely the other way. So anyway, as we're seeing this, what I noticed is right before we got this big hit, right? Now see those intermagnetic interplanetary magnetic field lines. Now look. See how they're all broken? There's nothing connecting right here. It's just completely open right where we're at. But yet you see these lines back here stretching. Okay, this way. Now again, these lines are supposed to be our connection to the sun, but they can also be a connection to something else. Okay, out there is what I'm trying to say. I'm not saying there's something back here, okay, right there at that specific position. I'm just saying that this is what our magnetics are looking at, like right there with those lines. I just want to point that out. But as we see here, right here, okay, now look, See how we're opening up again? So you think things are getting stretched. Not, you know, it's a very crazy looking signature there. It looks very quiet, but it's also, there is absolutely no connections out here. Okay? These lines are like getting pulled and, you know, pushed or whatever magnetically. Okay? Now as we go here, you got to see that. And again, I do understand that these things are meant to see stuff out in front of us, but we cannot just disregard what's going on behind either. Okay? You know, we really have to pay attention when something doesn't look like it normally does. There's a reason why it doesn't look like it normally does. Now, I don't know what the reason is. I'm not trying to say that I do. But what I'm trying to say is that we're getting hit here in the front, and watch. Okay? It's going to show it here in a second. See what we start doing? Okay? Now, I'm going to wait on some more data to come in, and I'll give you guys a better update. Okay, guys, I want to show you guys this just for the mere fact that I don't want you guys buying into the fact when somebody's going to come out here and tell you that something's eclipsing our sun. I'm going to sit here and tell you right now, nothing is eclipsing right now, okay? And the reason why I'm, like, again, this is also a little bit more evidence that we had something hit our magnetosphere, and I think it was that CME that was either moving at a different speed or whatever, like I just talked about. But what you're going to see here, it's going to look like an eclipse, but there's a couple things going on here. Even if it was an eclipse, most likely it was just a scheduled eclipse, not really scheduled, but a natural eclipse from where the position of the satellite's at. These things go into what they call eclipse seasons, okay? So the position of the satellite kind of fools us from its perspective to think that something's going in front of us and the sun. That's not what's going on when that happens. And I've explained that before. But I want to show you guys this because, first off, when I show you this, it's going to look like something's eclipsing it. But one of the main things it's saying that nothing is this is a straight line. Okay? So what's happening is that most likely that's probably either the shutter going closed or open. It might be doing some sort of calibration. I think in this instance, I think this got hit with that solar wind or that CME, and it caused it to probably go into some sort of a safe mode and kind of block itself, because these things are out there and they go into safe modes because they don't have the, you know, electromagnetic field to protect it like the Earth does. Okay? So these are out there without that protection. Now they're built to withstand a lot of this stuff, but they still go into safe mode because of what I just said. So watch this. I'm just going to run this through. Okay, you see that? See how it's a straight line, guys? And you're going to see it come the other direction here in a second, I think, when it comes back on. Nope, that one just put back on. Okay, because they take captures at ever many minutes. Okay, but I'm going to stop this right about there. Oops. Okay, now I want you guys to compare those two pictures. See the purple one? See how blurry that is? Now I'm going to tell you why I think that's blurry. I think that's when it initially got hit with that wind, or that CME, and it caused this satellite to shake a little bit. Okay, and that's why it's blurry like that. Now that's one possibility, and the other possibility is it was doing calibration, so it was actually moving when it took this capture. Just like, you know, if you take your camera at home and you move it back and forth real fast, start snapping pictures, they're going to be blurry, right? That's exactly what I'm talking about right here. So whatever caused that thing to move, whether it was doing it on its own or whether it was doing it from a CME or from a solar wind, the fact of the matter is this is not an eclipse. So don't let nobody tell you that it is. Okay? Please. So you can see it how it cleared up. Okay? But you can see that looks like a shutter. Okay? Honestly, it's just what it looks like. And it very well could be. It could be doing a calibration. Now, if we go over and look at the purple one, I think it actually shows it going during its calibration. Okay, see how it went the other direction? Okay, and you can kind of see it, how it pops out the other side. Watch. How it's opening, closing back up and stuff. You see what it's doing? Okay, and why I'm showing you this is you're seeing it open and shut in multiple directions. Okay, in the right angle directions. This is nothing random. So what I'm saying is that when it's doing this, sometimes when it comes out of safe mode, it recalibrates itself. So it has to do that. That's just part of its recalibration. And sometimes it's a scheduled calibration, so it just makes sure that it's accurate. Okay? They all have them. Everything that's looking at the sun is doing this. Not just this satellite. This is not an eclipse. Okay? So I just wanted to point that out, guys. All right? So, yeah. I am going to end the video there, guys. I'll come back with an update later on. So, yeah. Well, hold on a minute. Okay, guys, this is the calculator that I use, the conversion calculator, to go from kilometers per second to miles per hour. Now, you guys can get online and get that yourself. It's called Unit Juggler. It's free. I think it's actually in the Play Store maybe, or you can just go Google it or whatever. But there's thousands of them out there. Or you can just simply look it up and do the math yourself. But I'm going to convert what we just seen, which was 1950, I think it was. I'm going to tell you right now, this is going to be an extreme speed. Okay? I just know that it is. I haven't looked at it yet. I'm looking at this for the first time. But we're going to convert that, and I'm going to guess it's going to be around 3 million miles per hour. So, let's just see. Wow. That's 4 million miles per hour. Whoa. Wow, 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 wow. Man. Okay. So yeah. Obviously, that's fast. Again, I don't know what's going on there. So, that is what it is. But man, that is extremely fast. Wow. So anyway, guys, God bless. Yeshua saves, and you can drink this Kool-Aid.
driving me insane. And I know I just need one more chance to prove my love to you. And if you come back to me, I'll guarantee that I'll never let you go. Can we go back to the days our love was wrong? Can you tell me how a perfect love goes wrong? Can trying hard to make it right. Not long to go before I win this fight. Everybody's talking all this stuff about me. Why don't they just let me live? Tell me why. I don't need permission, make my own decision. That's my prerogative. It's my prerogative. It's the way that I wanna live. It's my prerogative. I can do just what I feel. It's my prerogative. No one can tell me what to